Hi everyone, once again we're back for another maths lesson. Today we are going to look at adding decimals. Before we do that, we are going to, as we always do now, start with our mental maths questions. Today though, I have put a shape in the top right hand corner rather than the clock face. So have a go at answering the 4 questions and see if you know the answer to the name of the shape in the top right hand corner. Pause the video now. Question number 1, which is greater, 7/10 or 60%? Well, 7/10 as a decimal would be 70%, because 7/10 is the same as 70 hundredths, and 70 hundredths is the same as 70%. So would you rather have 70% or would you rather have 60%? Of course, you'd rather have the 70%. Or the 7/10 as it appears in the question. Question 2, write 56% as a decimal. 57% should I say, is 0.57. Question 3, round 6.43 to the nearest whole number. If I'm rounding to the nearest whole number, I am looking at the whole number in the ones column, and I'm looking at the column 1 to the right of that, which will help me work out if I'm closer to the number I've just passed or the next whole number. In this case, I have a 4 in the 10ths column. 4 or less, you round back to the number you've already passed. The whole number before, 6.43, would be 6. So to the nearest whole number, that's what it would be. Question 4, work out 427 times 0. Anything times 0, anything multiplied by 0 is 0. So that would be your answer. This shape in the top right hand corner is a rhombus. Let's get into today's lesson. Our what says add decimals within 1. So I'm looking at adding decimals where the answer is less than a whole. Today we're going to, as I say, add within 1. So what I'm going to do is I'm going to show you lots of different representations to help you do this. But on the whole, when it comes to adding decimals within 1, we should have strong mental math skills to be able to do this without doing too much working out. When there are exchanges, there is sometimes room for a little bit of working out, but on the whole, generally, everything I show you today, you should be able to kind of picture and visualize in your head and think, actually, yes, I'm going to use a number line in my head to work out this value and this value, or I'm going to be able in my head to use a part whole model to help me work out what the answer to this is in my head. Today will help you work on those skills and those representations. Question number 1. We're going to start with something nice and simple, something like 0.2 add 0.6. Now straight away, if you're thinking, right, spot on, this sounds okay to me, I'm all right, I'm confident, and I know that it's 0.8. Correct, you are spot on if you think it's 0.8. If you're not sure or as confident with doing that, you need to kind of picture a number line in your head. You need to be able to, in your number line, picture 0.2, and you need to be able to picture 0.6. And what you are doing, you're adding on, you're finding the total. So you could either pull that down here and put it like that, or you could have pulled the 0.6 and added it to the 0.2. In the end, we got to 0.8, which hopefully we were confident with a moment ago anyway. But when you're adding tenths, because that's what it is, isn't it? 0.2 is 2 tenths, add 6 tenths. I'm visualizing that number line in my head. Let's just look at a second way. So number lines are one great way of doing it. You might have a look at an example such as this. 0.8 add 0.1. what am I doing if I'm looking at a part whole model? I'm looking at two parts that in total make a whole, hence the link with the lines. So the two parts of the part whole models give me the total in here. So we said a minute ago, adding tenths again, because I've got one number after the decimal point, 0.8 and 0.1 would in total give me 0.9. 0.8 in my head, adding on one more tenth would give me 0.9. As a percentage, or as a fraction rather, 0.8 would be 8 tenths. 0.1 would be 1 tenth. Using your year 4 knowledge, 8 tenths add 1 tenth would give me 9 tenths, which the decimal is 0.9. So that's quite straightforward, hopefully, for questions 1 and 2 today. Thinking about number lines, thinking about part whole models, but generally on the whole, using your mental math skills to help you visualize and answer these questions quite speedily. These are the sort of arithmetic type questions that you might find when you are looking at arithmetic test papers. Things that you need to be able to answer quite quickly. But it's all well and good saying answer it quickly. You've got to have those skills there to help you do that. So part whole models or number lines are good for sort of questions like that. You might also sometimes want to use a place value grid to answer questions. So let's have a look at a slightly trickier question, but we're not pushing the realms of difficulty too much here. We're going to have a go at trying to answer 0.26 add 0. Let's do 3. So yes, this is slightly more tricky because I've got two numbers after the decimal point here, and I've got one here, whereas before I just had one after each of my decimal points. But we're not, like I say, we're making it too tricky at the moment because this is mental math stuff really. So 0.26, let's have a go at work representing on a number line, on a place value grid, apologies. So 0 ones, 2 tenths, and a 600ths, 2, 4, 6. And then 0.3, 0 ones, 3, 3 tenths, 1, 2, 3. 0.3 is the same as 0.30. Doesn't matter which way you do it. I have in total 6 hundredths. I have in total 5 tenths. And I always must remember to put in my place value holder to give me my answer, 0.56. Again, quite straightforward. The only thing you've got to be super careful of here, year 5, and it's a mistake that sometimes people can make, is when you get a question such as 0.26 at 0.3, that you are not in your head mixing up your place value understanding. So the 3 has the same value as the number in the 10th column here, which is 2. Okay, the worst thing you could do here is do the 6 add the 3 or something like that, which would get you confused. But we've done quite a lot of place value work on tenths, hundredths, and thousands, so I would imagine that we're okay with that, hopefully. But again, it's picturing in your head the place value grid and then adding on your hundredths and your tenths and your ones if you did have any in any other examples. The trickiest thing to look at would be something like this, I suppose. For us today, let's just get rid of that. Let's have a look at something like 0.37. Again, we're still working within 1. Add 0.24. Now, straight away, you might have already spotted, well, I know what's different this time. I know what's a bit trickier this time, and if you do, brilliant. Let's just get these added on here. 0.3724, oops, 67, and 0.24, 0.24. Now, this time, again, I'm placing it in my head in the place value column. I have got something that's slightly trickier. I've got something slightly trickier because this time I've got an exchange going on. Because if I look in total, I have got 11 hundredths. I've got 7 here, add my 4 here, which would give me 11 hundredths in total. So what do I do in this instance is I group 10 of these together. So I'm exchanging, because I'm going above 9, and I can't put 2 digits in the same place value column. I've got to exchange 10 hundredths for 1/10, because we know they are the same. Picture that square in your head, that 100 square. 10 hundredths, 10 individual squares, is the same as 1 column or 1 row of 10, isn't it? Okay, we've done lots of work on that pictorial method. So I'm exchanging 10 tenths. No, not. I'm exchanging 10 hundredths for 1/10. So how many hundredths did I have in total? I had 1 remaining. I exchanged my 10 hundredths for 1/10, which is what I've done here with my extra counter. How many have I got now in total in my tenths? I've got 4 here, I've got 2 here, which means I've got 6 in total. I don't have anything in my ones column, but it's still important that I put it in. 0.61. So 0.61 would be my answer. Yeah, if I was to do that, I'll just do it really quickly here at the side in my column addition method. Because I would always check my answer, particularly with something like this, just to make sure you don't make any silly mistakes. When you do have any exchanging going on, I would always double check using a formal method to help you make sure that you're on the right lines. If it hasn't got any exchange, like the examples I've already shown you, then it's definitely a mental method that you can practice using either number lines, place value, grids, or part whole models. So what did I do? I had 1100, didn't I? So I put my 1 down, because that's what I had remaining, after I exchanged 10 hundredths for 1/10. I show my exchanges on the line like so, which is what I did with my place value counter. 3 tenths add 2 tenths is 5 tenths, add on my exchanged one, which would give me in total 6 tenths. I didn't have anything in my ones column, but it's still important that I put the number in there. 0.61 is my number in its entirety. Don't forget the decimal point, and that will help you with that. That's kind of the majority of what you need to know for today's lesson. Number lines, place value grids, part whole models, and then checking using the formal methods when you do have any exchanging going on. There's one problem-solving question right at the end of the worksheet today that you will need to know a little bit about, or you'll need to recap a little bit of understanding of measure, which we have covered in class before we closed. So we know that 1 litre is so many milliliters. Wonder if you can remember how many litres are in, how many milliliters should I say, are in 1 litre. If you're thinking 1,000, you're thinking spot on. You're absolutely spot on. So if I know that 1 litre is 1,000 milliliters, I know that half a litre is, hopefully you're thinking 500 millilitres. If you are, you're spot on. Half of 1,000 is 500. What about 1/10 of a litre? I'm dividing that top number by 10. 1/10 of a litre. Dividing it by 10, you're moving your digits one place to the right. How many millilitres are in 1/10 of a litre? 100 millilitres are in 1/10 of a litre. What about 7/10 of a litre then? 7/10 of a litre. Well, if 1/10 is 100 millilitres, 7/10 would be 700 millilitres. Millilitres I need to run out of space. So that's a little bit of a recap of measure, which will help you with the decimal work that you will need to help you answer the last question on the worksheet today. Okay, you'll understand it when you get there, hopefully using those conversions or working on conversions, something similar to that. So have a go. That's it for me today. Adding decimals within one is mostly mental methods to help you work out the answers, but it's using these pictorial methods that I've shown you to help you understand that. And it's checking when you do have any exchanges in any calculations using the column methods, the formal methods, to check your answers are correct. Good luck. I will see you tomorrow.